again, and first thing we need to do is set it equal to 0. So we're going to subtract 7. We're going to add 11x. So this will be 6x squared plus 11x minus 7 equals 0. So I put it in standard form. All right. You could technically put the minus 7 second, but that wouldn't be standard form. Once you have your trinomial, look to see if there's a GCF. Is there a GCF on this one? No, it would normally be the 6, but 6 doesn't go into 11 evenly. So there's no GCF. So we're going to use that little slip and slide rule that I taught you last week, which means you're going to take the 6 and multiply it by the negative 7. And then you'll have x squared plus 11x minus 42. Makes it a lot easier to factor. So I'm going to write my binomial times my binomial. Got my parentheses. Square root of x squared is x and x. And then the hardest part is figuring out what multiplies to get negative 42, but adds or subtracts to get 11. Somebody needs a calculator. Anybody got it today? 14 and 3 is correct. Do you know which one is plus?
14.
The 14. It's got to be x plus 14 and x minus 3 because that middle term is positive. That's how we knew that one the plus should go with the 14. Okay? So we just multiplied by 6. We have to unmultiply by 6. So we're going to divide by 6 and divide by 6. And then just see if we can reduce before we do our slide, right? So obviously these are both even, so they divide by 2. This will be 7 and 3. And then we want to slide the 3 out front of the x, and we have 3x plus 7. This one we want to, we can reduce first as well. So 3 goes into 3 once, 3 goes into 6 twice, so we're going to slide over that 2. So we have 2x minus 1. All right, and we've got our 2 binomials. Now in problem 69, we ended up with this nice pretty number of 7. Are we going to end up with nice pretty numbers here? No, what are we going to end up with? Fractions, okay? So when we set 3x plus 7 equal to 0, subtract 7, you get 3x equals negative 7, and then you have to divide by 3. That gets you your fraction. Just leave it as a fraction. If you reduced properly over here, you shouldn't have to reduce it. It should already be reduced, right? Okay? Then you take your 2x minus 1, set it equal to 0, add 1 to both sides. You get 2x equals 1, divide by 2, and you get x equals 1/2. So this one you have 2 different answers. That's normally how it'll be, not like 69 where we had 7 and 7. Any questions on box 71? All right, box 73. Let's look for a GCF. Is there a GCF? On this one there is, right? When there's a GCF, it's usually that leading coefficient, right? Which is 7. So we're going to factor out the 7. We end up with x squared minus what? 9. Do we like 9?
Yes.
Yes, we do. It's a perfect square, right? If you go back to your perfect square list, it's right there. So we're going to write our 2 sets of parentheses for our binomial times our binomial. Bring down that 7. Take the square root of x squared, which is x and x. Take the square root of 9, which is 3 and 3. And what are my signs? Plus and minus. Okay? Now, if you try and take all of these factors and set them equal to 0, you get something weird first, right? Does 7 equal 0? No, that's like an extraneous answer. You don't need it. But these two, you'll definitely get something. So this is going to be negative 3, and this one's going to be positive 3. It's really just kind of the opposites. So if you have nice, pretty numbers, they're kind of easy. It's the fraction ones you got to watch out for, okay? And you'll get those whenever you have that leading coefficient. All right?